Bismillahirrahmanirrahim. Starting with the great name of Allah, the most merciful and beneficent. My name is Avesur Rahman, and today I'm gonna discuss with you guys quicksort. So what is quicksort? Quicksort is another sorting algorithm that follows the divide and conquer strategy. In this sorting algorithm, we pick a special element, pivot, and the given array is partitioned with respect to the pivot element. Elements that are smaller than the pivot will be in one partition, and the elements that are greater than pivot will be in another partition. I mean here that the elements which are smaller than the pivot will be on the left side of the array, and the elements which are greater than the pivot element will be on the right side of the array. Now I will tell you the origin of the quick sort. The quick sort was developed in 1959, and later on it was published in 1961 by Tony Hoare. Actually, Tony Hoare was visiting student at Moscow State University at that time. He worked on a project on machine translation for National Physical Laboratory. So to fulfill this task, he discovered quicksort, and later the code was published in 1961. Now let us come how the quicksort works. So consider in this case we have selected our pivot element is 6, which lies in the middle of the array. So as the algorithm says that the elements which are less than 6 will be on the left side of the array, and the elements which are greater from the 6 will be on the right side of array. As 5 is less than from the 6, 4 is less than from 6, 3 is less than from 6. So all these 4, 5, 4, 3 will be on the left side of the array, and the elements which are greater are 8 and 7, which will be on the right side of this 6. So I'll write piece of code, array of low is less than our pivot. So now look it here on the position array of low, array of 0, array of 0 has 8. 8 is less than 6. No, it's not less than 6. So I will write here another loop, while loop, that while array of high is greater than pivot. Now what is on the array of high? Array of high is 5. So on the index 5 I have 7. 7 is greater than 6. Yes, it is greater in this 6 condition, true. So just decrement in the value of high. High will be decremented. Now the high will be 4. Again on index 4 this time value will be checked with the pivot element. On index 4 we have got 3. Is 3 greater than 6? No, it's not greater than 6. Now in this case 8 was not greater than the pivot element, and now in this case, which in the array of high, in the array of 4, which possesses 3, 3 is greater than 6, it's false. So what will be actually done here? So these will be swipe array of low with array of high. These element will be swiped. Array of high will be swiped with array of low, just in this condition. 8 will becomes here and 3 will become here, just like that. While with this swipe also it will be increment in low, and there will be decrement in the value of high, and the rest of the array will be that 8 will be take on the position of 3 and 3 will go to the position of 8. So the rest of array will be like that. Now Next time the value of low becomes 1, so while array of low less than pivot, now on the low is 1, here is 1, so here is 1 because the low value has been incremented. So 5, array of 5 has 5, array of 1 has 5, 5 is less than 6. Yes, the condition is true. I will need here to add another condition. It will increment in low. So the condition is true. Now increments in low. Now low becomes 2, array of 2 it's 6, 6 is less than 6, the condition is false again. Now it will be check array of high. So the last time it was decrement in the value of high becomes 3. On the index 3 we have got 4, 4 is greater than 6. No, it's not greater than 6, the condition false again. Swap the array of low with the array of high. So array of high is 3 and the array of low is 2, so this 6 will becomes here and 4 will becomes here, just like that. I will need my array 1, just like that. 3 is its own position, 5 is its own position. Now 4 will becomes here, 6 will be go here, 8 will be on his own position, and 7 will be on this own position. So write the indexes 0, 1, 2, 3, 4 and 5. So the 6 comes on the index 3 and the 4 comes on index 2. So that's what the algorithm says, and the value of low will be incremented and the value of high will be decremented. So low becomes low becomes 3 and the high becomes 2. So when the value of low is becomes greater than the value of high, we will also write here another condition that will check the value of low. So while low is less than or equal to high, this condition, these condition are inside in this condition. This is our outside condition, and this condition, these three are here. Now the next time our pivot element will be 4. So this will be our pivot element. So same as that, the elements which are smaller than the 4 will be on the left side, and the elements which are greater than this 4 will be on the right side. So that's how the quick sort works, and we can sort our array. Now I will coming towards the code. I will write the code for the quick sort. So here I had opened my Java NetBeans. So first of all, I will write the code for the partition element. That's how on the basis of the pivot element the array is being partitioned. So I will write here in partition function that will take 3 arguments. One is array and one is lower index and high index. Now first of all, we will select our pivot element. Our pivot element will be array of low plus high divide by 2. It will gives the middle element of the array as our pivot element. Now here I will write down the condition while low is less than or equal to high comes here, right, while array of low is less than the pivot element increment in low. Now here while This one for the right side. Array of high is greater than the pivot element, so decrement in the value of high. And at last, if low is less than or equal to high, so we will get the array of low value on temp. This one is actually for swapping the elements which are greater than the pivot element will be shuffled on the right side, and the elements which are on the left side will be shuffled to the left side. So temp, we will keep the value of lower index in the temp, and on the lower index we will get the value which is on the higher index, which is actually smaller than the pivot, will becomes on the left side, and on the high side it will becomes the greater value which is so far in the temp. And as with this, we will increment in low and decrement in the value of high. So that's for the partition, and we will return here lower index value. So that's piece of the code is just for the partition element. Now I will write the code for the quicksort recursion. I will write here a method. It will recursively method. So I will like void quicksort recursion, I mean QSR, right? So it will also take array and low index and high index value. So int by here it will call to the partition method, and the array and the lower index and the high index value will be passed here. And if low is less than the pivot minus 1, I mean here that the values which are on the left side, so our next pivot will be 4. So this is for the left sub array. So again it will call to its own method QSR and the array and the value of lower, and this time we will want our pivot minus 1. So this time our pivot will be 4. That means at the one index less than the mid. And suppose if pi is less than high, then again it will also call to its it will call to its own self, that's recursion, and pi and high will be passed. So actually this line of code is for the left sub array, and this line of code is for the right sub array. Now in mine I will just make an array consists of 8, 5, 6, 4 and 7. Oh sorry, 8, 5, 6, 4, 3 and 7. So that was our actual array that we discussed in these videos. That's why I write it here. So int length array dot length, it will gives us the length of the array, and here I will write the class name to make the object of this class equals to new quicksort recursion, and this object will first call to our quicksort, and initially the lower index value is 4 and the higher index will be length minus 1, because the length of this array is 1 2 3 4 5 6, and as we know that the array start from the 0, so there will be no such element that it's in the array. That's why I write here length minus 1. And another method to print this array will be void print int array. I will use here for each loop, for each loop. So for each element in this array will be comes here in I, and it will be printed for us. Now check, there's no error, so I will run this code. It's taking time. Oh, what's happened? Doesn't give us result. Oh, so sorry, we didn't call for our print method. That's we call for the our print method. Now, oh, I will remove this ln so it will show us this whole thing in a single line. Now look it to array. This array is being sorted. What we have earlier 8 5 6 4 3 7. Now the sorted array is 3 4 5 6 7 8. So our array is sorted. Now how this program works, I will tell you. First of all, we have take an array that consists of 6 elements. Here we find the length of this array, and it stores in length element, and we have made the class the object of this class, and through object we call to our method quicksort recursion, and we have passed this array, and initial index is 0 in array, so we have passed the 0 and length minus 1, the higher index, this one, which is 5. So it will comes here to the quicksort recursion method. The array will becomes here, and the in low the 0 will comes in low, and the higher index will becomes in this integer high. Now here we have taken an integer pi which will return the lower value from this partition method, and in this we have called to the partition method, and to the partition method we have passed our array and our lower index and our higher index. So it will call to the partition method. The partition method takes these 3 arguments: our array, the lower index and higher index. So in this partition we will select our pivot element. So in this case we selected this 6, which lies in the mid of the array, So we are told that our pivot element is array low plus high, which is 0 plus 5, which give us this 2. So on the 2 we have got a 6, which was our pivot. So then we will start this, check this, that low is less than or equal to high. Yes, because low is 0 and the high is 5. 0 is less than or equal to 5. Comes here, check here at array of low is less than pivot. At what was here, at array of low has 8. 8 is less than 6. No, it's not less than 6. So this thing will not run, so the value of low will not be incremented, and it will comes here. Check here, array of high, array of 5. Array of 5 is greater than pivot. What was on array of 5? 7. 7 is greater than 6. Yes, it is say greater than 6. Now comes here and decrement the value of high. High becomes 4. Check again, array of high, so high becomes 4. Array of 4, what is on array of 4? 3. So 3 is greater than this pivot element. No, it's not greater than this pivot element. So comes here 0. Last time the value of high was 4. So 0 is less than or equal to 4. Yes, the condition is true, and this will be, it will be swiped with 3. Here we kept the value which is on the lower index. On the lower index we have 8, so 8 comes in temp, and on the higher index we have 3, this thing, and 3 will come on the lower index on 0 position. On the high position on index 4, the value of temp will be is assigned to a higher index, and the value of temp is 8, so 8 will assign to higher index, and as well as the value of low will be incremented and the value of high will be decremented. Again, this will be checked. The next time the value of low becomes 1 and the value of high is 3, so 1 is less than or equal to 3. Yes, it is. Now on array of 1, the value will be checked. What is in on array of 1? On array of 1 we have 5. Is 5 less than 6? Yet it is less than 6. It will increment in the value of low. Low will becomes 2. Check again on index 2. Index 2 we have got 6. Is 6 less than 6? No, condition is false. 6 is equal to 6. Now comes here, check this array of high. Array of high, the last time the value of high was 3, so 3 is on index 3 is 4, so 4 is greater than 6. No, it's not greater than 6. So comes here and swipe this 6 with this 4. So 6 will becomes here and 4 will becomes here in this array, and the value of low will be incremented and the value of high will be decremented. So the value of low becomes 3 and this will becomes 2. So at last our this is false. 3 is less than or equal to 2. Now 3 is greater than 2, so it will return this lower value. What was the lower value? So it was 3. 3 will be assigned to here to the pi. Now again it will be checked. Now this is for the left sub array. This will choose the pivot and the left sub array. So 0 0 is less than, what was here? Here it was 3. So 3 minus 1, 0 is less than 2. So again it will call to the quicksort recursive method to its own self, and array will be passed and a lower index value will be passed, and on the place of the high index this will be passed, which is and 3 minus 1 2, so high becomes 2 and it becomes a 0 and it becomes the array, and again the whole process will followed again, and this thing is for the right sub array. So in this way our quicksort works, and in this way the array is sorted. So that was all that quicksort how it works. Now we will look at that how the quicksort works in the worst case scenario. So suppose we have an array, we have a problem of size n, and we have selected our pivot element at the starting position, and our pivot element is also smaller such that there is no smaller than this pivot element. So as we have discussed in the algorithm of in the quicksort, that the elements which are smaller than the pivot element will becomes on the left side, and the elements which are greater than this pivot element will becomes right side. So here in this case our pivot element is already smaller than all the elements in this array, so it will not shuffle. Now and at the next time x will be in its own position, x will be here in its own position, and y will be selected the next pivot element. Again the y is smaller such that all the elements are greater than this y. So you will understand that the quicksort works in the worst case. It works in the sorted array, and we also select our pivot element such that it is smaller or it is greater or in from the all the elements. So in this case we have select the smaller element or smaller value or pivot. So again it will done n minus 1 times comparisons, or our problem will becomes n minus 1 and so on. Again it will check x will be in its own position, x will be in its own position, y will be in its own position. Now the next element to be selected for the pivot will be z. Again this z is our pivot element, and this is also smaller from the all the values that are in this array. So again it will done n minus 2 times comparison with the whole array. So look it here in this tree, we have a problem of size n. We break it down to the size of n minus 1, then we break it down to size n minus 2, and so on. This process will be open n minus 3 and n minus 1 times. So at this n minus 1 it goes c of n times, and at this place it goes cn minus 1 times, just like that. At the last it will becomes 1. So we are looking here that when we add this n plus n minus 1 plus n minus 2 and so on. So actually no, you that it follows the sum of the natural numbers. So the sum of natural numbers, and we have the formula of sum of natural numbers. If we have this type of series, we can simply write n into n plus 1 divided by 2, which is the formula of the sum of n numbers. Sum of n numbers. So we have here a formula of sum of n numbers. Now n into n, it becomes n square, and divided by 2 plus n into 1, so it becomes n, and n divided by 2. We select this dominant side, n square by 2. So the quick sort works in the worst case is big O of n square. So the worst case of the quick sort is big O of n square. So let us suppose if our n is 5. Our n is 5. So 5 into 5 is 25. So if our problem is 5, it will done it will solve in 25 operations. After 25 operations we will get our result. So that was the worst case of quick sort. Now I will discuss the best case of the quick sort. In the best case, we selected the pivot element in the mid and we divided the whole array into n minus 2 n divided by 2 size. This whole array of n is divided into n by 2 such that this left sub array contains n by 2 elements and this right sub array also contains n by 2 elements. N by 2, n by 2, and the whole array contains n elements. Now again the pivot is in the middle and the array is furtherly divided into n by 4 and n by 4. So here the array is divided in the middle, and so on. Further, I have no place. I will write here this. Now this array will also divide it. Here comes n by 4, n by 4. Again this array will be further divided into n divided by 8, n divided by 8. So I will write here the equation for this 2t n by 2 plus n. This 2 specifies that we are dividing the array into two parts, and this n by 2 specifies that we have n by 2 elements in each array, and this n is for the comparisons uses in this breaking arrays. So that's why I have add here n. Now at the next time this will divide it. This will be like this: 2 into this 2t into n by 4 plus n by 2 plus 2n. Because the next time the array is divided again into n by 4, n by 4, so that's why the array is divided again. So 2 into 2 becomes 4t, n by 4 on place and n by 2 is in its own place. So look at this, we have got 4 here, 4 here, and 2 here. So what is 4? 4 is the square of 2. So we can write like this. Now we have supposed this square as a chi. We can write such that 2 power chi, and we have let this to n. So taking log on both sides, we are taking log on both sides because we have to find this value of k. So taking log on both sides, it will becomes log n. So k will comes here, that's the rule of the logarithmic. Log 2 equals to log n. So log 2, we know that log 2 is 1, so k into 1 becomes k, and k equals to log n. So we will put the value of k here, which will gives us n into log of n. So this will gives us here, after we putting log n in place of k, so it becomes n log n. So that is our best case. So the best case of the quicksort is n log n. So let's suppose that the size of the array is 10. We have 10 elements in the array, so putting this in this formula 10, so becomes 10 log 10, base is 2, so 10 and 2.10, so log 10 is 3, so the answer is 30. So if we have the size of array is 10, it contains 10 elements, so it will take 30 operations to solve this problem. So that's all about the quicksort. I have discussed the quicksort algorithm, concept of the quicksort, and the code of the the code of the quicksort, the worst case of the quicksort, and that was the best case of the quicksort. So that's all in this video about the quicksort. Thank you to you all to watch this video.